Let us move on to advanced level questions in this topic. So I'll just explain you this question. There is a pipe from which there is water coming in, and also there is a small hole here. So what is happening is, as this water is coming, water is leaving this. What happens is, initially water leaving will be very less because we know the speed is root 2 GH, as H was 0 initially. Very less water is coming out, but a lot of water is coming in. So what happens is, due to this, the height starts increasing. Okay. And what the question asked is, what is the maximum water height H max that comes? And the next is, plot the variation of height width as a function of time. Okay. So what can we write here? Tell me. So water is coming at Q. Okay. And water is leaving here. So what is the amount of water leaving? Volumetric flow rate is area into speed. So I can say this is nothing but area A into speed is root 2GH if H is this height. Okay. Now coming minus leaving is how much is increasing here. So I can say water which is coming in minus water that is going out equal to the rate of increase of water here. That is nothing but what? A times dH by dt. So this height is increasing. Okay. Now when this becomes maximum, what happens? Tell me. When the height becomes maximum, the change in height is 0. So that means dH by dt is 0. So at H max, what can we say? dH by dt becomes equal to 0. So we can directly write Q equal to A into root 2G max. Okay. Now we just need to put the values here and we are completed. Okay. What will be H max? Tell me. Q square by A square into 2G. This will be H max. Okay. Now what will be the value? I just want you to tell me the values. What is Q? 4 liter per minute. So I'll just convert everything into SI. So Q equal to 4 liter is how many meter cube? 4 into 10 power minus 3 meter cube. Per minute we are converting to seconds by 60 seconds. Okay. Next, area. He has given the diameter of the hole as 6 millimeters. So what will be the diameter in SI? That will be 6 into 10 power minus 3 meters. Okay. And so what will be area? Pi d square by 4. This will be the area of the hole. You can put G as 10, put these values here. Okay. And you will get the answer. You should get this answer as 27.4 centimeters. Just do the calculations and cross check it. Okay. This should be your answer. The next thing that he has asked is, plot the variation of H as a function of time. So if I draw the graph here, H as a function of time, what happens to him? Initially, what is height H? It is 0. Finally, after long time, it will become H max. H max like this. So finally, at t tends to infinity, it will be H max, and here it is 0. So how would the graph? Will it be linear? If it is linear, it will cut across this. It can't be curving upwards. Why? Because it will increase like this. So the only option is it has to be like this. Has to be like this. Okay. And so this will be the variation of height as a function of time. Let us move on to the next advanced question. So we have a pipe, bent pipe here, and there is oil going in and coming out like this. We need to calculate. So first he has asked what is the pressure of oil at Q. So what is the pressure here? And he has given the pressure here as 280 kilopascals. It is entering here at 280 kilopascals. So yes, we can write Bernoulli's equation here, P1 plus half rho V1 square. H is the same. He has not given any height here. So it is just, in a horizontal plane you can take it. So height is the same. And so we can directly write, just we'll write here P1 plus half rho V1 square equal to P2 plus half rho V2 square. Okay. We need to find what is this P2 or PQ here. So P2 equal to P1 plus half rho. See, the area is becoming divided by 4. So the velocity becomes into 4. So this velocity becomes into 4. So this becomes half rho 16 V1 square. So I'll just put it here. It becomes half rho. If I bring this, so P2, if I bring this here, it will become minus half rho 15. So V1 square. The V square which has given 4 meters per second. So that's it. We can put in the values. What do we get? P2 equal to P1 is 280 kilopascals into 10 power 3 minus half into specific gravity of oil is given as 0.9. So the density will be 900 into 15 into V square is V is 14. So this will be 16. Okay. You can just solve for this and you'll get the value P2 as P2 you'll get as, just a minute, I'll give you the answer, 172 kilopascals. This is what you'll get the pressure here. Okay. The next part of the question is the force required to hold the bend in place. So to find the force required to hold the bend in place, what we'll do is we'll take this part of the water which is there here. Inside this we'll take this part of the water. Okay. We'll write all the forces on it and we will, the net force equal to rate of change of momentum, right? So here, what is the force? Tell me. Here the force on water is P1 into A1. This is the force on water here. What is the force on water here? In which direction it will be? In this direction. P2 into A2. Okay. Another force on water is the pipe force. Okay. So I'll just write this as some F1 bar and this I'll write it as F2 bar. This has direction. Okay. It is not just the magnitude. It has some direction. Now I can say that the net force, that is the net force on water equal to rate of change of momentum. Rate of change of momentum. On which water? On this water here, whatever you are seeing. Not the water that side, not the water this side. Okay. So net force on water is, one is due to F1. Okay. Due to the water which is there here, the force is F1. Due to the water there, the force is F2. What is the other force? Due to the pipe, plus equal to rate of change of momentum of water. What is the rate of change of momentum? Initially, what was its momentum? Its momentum was in this direction. Finally, its momentum is in this direction. I'll just write, this dp by dt. is the rate of change of momentum of water. What can I write as this dp by dt? Tell me. I'll just see this one. We know already p1 a1 values we have, f2 p2 a2 values we have. We need to find what is this. Okay, and dp by dt we will find out. From there you can calculate what is force on the pipe. So what is dp by dt? So change in momentum. First we'll write dp equal to mass into change in velocity. So that is nothing but dm into v final bar minus v initial bar. Okay. What is dp by dt? dm by dt into v final bar minus initial. What is mass flow rate? Rho av, right? So rho into, we can write anything, a1 v1 or a2 v2, anything is fine. Rho, let us say we write a1 v1 into velocity final is v2 and this is v1. So this is v2 bar minus v1 bar. So we have got the rate of change of momentum also. So we have all these quantities, and when we calculate all this, when we put in the values and calculate, we get the value of force on pipe. I'll just give you the answer for this. So force on pipe equal to 76 kilonewton. Okay, just put in all the values. He has given everything. We have found out the pressure here also. Using that, you will get 76 kilonewton.